Hi everyone. So today we're going to be doing a lesson on angle measure. So a lot of this lesson is going to be very introductory, and then we'll use these skills in the upcoming lessons. So let's first talk about informally how we measure angles. So angles are measured based on how wide it opens. We measure an angle by the length of rotation that occurs to get the initial side to the terminal side. Actually, let me color code these with the pictures that we're going to draw. So we have our initial side. And so let's actually jump into the diagrams here. So the initial side, we always start at. And so these are going to be my initial sides for these two types of angles that I'm going to go ahead and draw. Now they're going to open up a certain direction, and that makes the angle either positive or negative. So if it is a positive angle, you are going to rotate counterclockwise, okay? And you will end up at the terminal side. So we measure the angle based on the amount that we are rotating. And so this right here, we have the terminal side. And so typically we call this measurement theta. That's usually the variable that we use. Now, if it's a negative angle, you move from the initial side and you're going to open up clockwise. And so that amount that you've opened up, you end at the terminal side. It's kind of called the terminal side because that's where it stops, right? And so this would be the terminal side in this case. And then that amount that was opened up, we call that theta. So a positive angle, you go counterclockwise in your rotation. And for a negative angle, you go clockwise in your rotation. Okay, so let's move on to the different ways we measure, so the different units of measure. Just like when you are measuring like a distance, right? You can use feet, you can use inches, you can use meters. There's a lot of different units that you can use. And we have two different units of measure for angles. You either measure them in radians or degrees, and you can convert back and forth, just like you can convert inches into feet and vice versa. If a circle of radius 1 is drawn with the vertex of the angle at its center, so remember the vertex is basically that point on your angle where it comes where the initial side and the terminal side meet. And so then the measure of this angle is in radians. And so let's give you some examples. Okay, so we know that when you do a full rotation around the circle, right, we are rotating 2 pi, right? That's the circumference of a circle. And so that angle is equivalent to how far along the circle that you've moved. Okay, so if theta equals pi over 2, it means we are moving along our circle pi over 2 of the full 2 pi. Now, it might be helpful for you to think of this as 0 or 2 pi is kind of like your end, right? If I go all the way around the circle, I've traveled 2 pi. If I go halfway, then that's pi, right? That's half of the rotation. And then that would make this up here would be pi over 2. So if I'm rotating pi over 2 along my circle, this is where my terminal side would meet. Let me redraw that. Okay. And so it turns out pi over 2 is actually equal to a 90-degree angle. Okay, let's do one more. So number 2, we're going a distance of negative pi over 6. Now, be careful here because this is a negative angle. Instead of rotating from that starting point counterclockwise, we actually want to go clockwise instead. And we're going only a distance of pi over 6. So think of what we just did was pi over 2. Pi over 6 is significantly, right? It would be out right there, significantly shorter of a distance. So I'm going counterclockwise about pi over 6, and that is where I stop. That's where the terminal side gets drawn. Okay, so this right here, this angle, theta, would be about negative pi over 6. All right, so go ahead and pause here and do 3 and 4. And then we will go ahead and do them together. Okay, so hopefully you had an opportunity to do 3 and 4. So for number 3, we're going 3 pi over 4, and it's a positive angle. So I want to go counterclockwise in my rotation. And think about the fact that this right here would be pi. We're going a little short of pi, right? 3/4 pi. So it looks like you're probably going to end up about right here. And so then we draw in our terminal side of this angle, and we have our theta right here. Okay, number 4, it's trying to trick you a little bit because we always think in terms of 2 pi as the full way around the circle. But a good way to think about this is pi is about 3.14, right? And so if we go all the way around the circle, we're going 2 times 3.14-ish, right? About 6.28. Well, we only want to travel a distance of 2. And if you think of the fact that pi is here and it's about 3.14, I don't want to get to pi. Now, up here, we know is pi over 2. Well, 3.14 divided by 2, that's still going to be smaller than 2. So I need to go slightly past pi over 2, but I don't want to go past pi. And so we can kind of get a fair estimate about where 2 radians might be. So not all radian measures are going to have a pi involved in them. That would be like an exact form of writing your radian measure, but you can move to radians. It's just not quite as nice to be able to identify as having a radian measure in terms of pi. Okay, so we have right here, whoops, would be our theta. Okay, so let's go ahead and move on. So in the next section, we're going to be talking about how to convert between these 2 different units of measure for angles. So we have radians and we have degrees, and we can actually pretty easily convert between the 2. So since a complete revolution around the circle is 360 degrees, then we know that 360 degrees is actually equal to 2 pi radians, right? A full rotation around the circle. Using this fact, we can convert between the 2. So we can do a little bit of algebra to show. So we know 360 degrees is equal to 2 pi radians. And I'm going to just use rad for short. Now, if I divide both sides by 2, I know that 180 degrees is equal to pi radians. And let's go ahead and start there with our conversions. I'm going to show you what 1 degree equals and what 1 radian equals. Okay, so to figure out what 1 radian equals, I can divide both sides by pi. And so 180 degrees divided by pi actually equals 1 radian, okay? And then to figure out what 1 degree equals, I can divide by 180 on both sides. And it turns out that 1 degree equals pi over 180 radians. Okay, so let's go ahead and look at how to convert. So to convert from radians to degrees, think about what you would do to either side of the equation in these 2 pieces, right? You want to go from radians to degrees. So from radians to, we're going to degrees to radians first. So from degrees to radians, we want to multiply by pi over 180 degrees, okay? Think about the fact that the degrees are getting like kind of quote unquote canceled out. Then to convert from radians to degrees, you multiply by 180 degrees over pi radians, okay? And think about the fact that 180 over pi, right? 180 degrees is equal to pi radians. So you're really just multiplying by 1 in disguise. Okay, so let's take a look at some conversion examples. So number 1 says express 60 degrees in radians. So we take 60 degrees, because we're going from degrees to radians, we want to multiply by pi over 180 degrees. See how the degrees cancel out, right? The units, so we're left with a pi radian. Okay, so 60 over 180, well, both 60 and 180 are divisible by 60, right? So we could actually reduce 60 over 180 as 1/3. So it actually equals pi over 3 radians. And so you might notice that from the unit circle, 60 degrees and pi over 3 radians are equivalent. Okay, let's do one going from radians to degrees. So we're going to take pi over 6 in example 4. And to convert this to degrees, we're going to multiply by 180 degrees divided by pi. Now notice the pi's cancel out. 180 degrees divided by 6 is 30 degrees. And so pi over 6 radians is equal to 30 degrees. Okay, go ahead and pause here and go ahead and do 2, 3, 5, and 6. Please check your work with my solutions that are posted on my website, mrsfitzmath.com. Also make sure for these problems that you fully simplify any fractional answers that you get, reduce them, go all the way. I want to make sure all of your answers are fully simplified. Okay, let's go ahead and talk about how to draw angles in standard position. So these are all blank, so you need to get some information from me, what we're going to draw. And so an angle that's drawn in standard position has its vertex at the origin and its initial side is on the positive x-axis. So let's do a couple examples. So the first one, we're going to draw theta equals pi over 3, and we're going to be in radians right now. So the initial side is on the positive x-axis always. So this is our initial side, it's our starting point. The vertex, I'll put a little dot, is going to be at the origin. So if I'm drawing pi over 3, we are going counterclockwise because it's a positive angle, and we're only moving pi over 3. Remember, this up here is pi over 2, this is 0 or 2 pi, if you go all the way around, right? We have pi, and 3 pi over 2 is down here. If we're rotating to pi over 3, well, it's a little more than pi over 4. So it's right up here somewhere. And so now we have an angle, theta, drawn in standard position that represents pi over 3. Okay, the next one that we're going to do is theta equals 9 pi over 4. We're going to keep it in radians. So we have 0 to pi. Pi over 2 is up here. Pi is here. I know it's kind of smushed over there. And then 3 pi over 2 is down here. Okay, so once again, our initial side is on the positive x-axis. We're going to rotate clockwise again. Now we're going 9 pi over 4. So I know that's for sure larger than pi, right? Because that would be 4 pi over 4. But actually, going 9 pi over 4 when I'm rotating, that's actually larger than 2 pi, because 2 pi actually equals 8 pi over 4. So it means we're going pi over 4 beyond 2 pi. So this is what that looks like when it happens. You're rotating a whole 2 pi, and then you keep going an extra pi over 4. And that is where you draw your terminal side. And so this is actually your angle right here, theta. Okay. And so what we call this, because it's actually coterminal, we call it coterminal to pi over 4, because if I were to draw the angle pi over 4, it would look identical. It lands in the same place. Turns out there's an infinite number of angles that land in the same place. Okay, next we're going to do an example of a negative angle. So theta equals negative 5 pi over 4. Okay, so we have negative 5 pi over 4. We once again start on the initial side. Now negative 5 pi over 4 means we're actually now rotating clockwise. Now 5 pi over 4 is a little further than pi. So a pi distance is halfway rotation, but we're going to go pi over 4 beyond that. So we land right about here in quadrant 2. Oops. So this is our theta. Whoops, theta I guess is right here because it was that negative angle. Okay, the last one we're gonna do, we have theta equals, we'll do negative 13 pi over 6. Okay, so this one's a little bit of an odd one, negative 13 pi over 6. It's not one that we really memorize on the unit circle, and it's kind of a strange length. So this one you have to be really careful about. And so you have to do a little bit of thinking. Well, I know that 2 pi, right, would be 12 pi over 6. This is going to go beyond that, and we're going to go clockwise this time. So we are going to go with our initial side. We're going to rotate clockwise. Now, negative 12 pi over 6 is negative 2 pi. That's a full rotation, but we still have an extra pi over 6 to go. So this is actually where your angle would open up, and it's coterminal to negative pi over 6. So that is where your angle theta would land. All right, so now that we've learned how to draw angles in standard position, we are gonna kind of talk a little bit about coterminal angles and how to find them. So two angles in standard position are coterminal if their sides coincide. So basically, think about the fact that if you go to an angle and then you go 360 degrees or 2 pi again, either direction, you'll land in the same location. So it turns out you can take any angle and add or subtract any multiple of 360 degrees, or 2 pi if you're in radians, and you'll land in the same place. So let's talk about an example. Let's look at number 1. It says, find the angles that are coterminal with the angle theta equals 30 degrees in standard position. Now, we're going to give a couple of examples. We're going to give a positive coterminal angle and a negative coterminal angle. So if I were to draw this out, now we're in degrees, so this would be 0 or 360 degrees. This up here is 90, we have 180, oops, and we have 270 down here. So 30 degrees, we rotate counterclockwise, and we're only going 30 degrees, looks like this. Now, if I take 30 degrees and I add 360 degrees to it, I get 390 degrees. Turns out this is also coterminal, because if I go 360 and then an extra 30, notice we land back where we started. Okay, so that's one example of a coterminal angle. Now the next one, what we can do, instead of adding 360, we can subtract 360 to get an example of a negative coterminal angle. So we end up with negative 330 degrees. Well, let's see how that works out. I'll do it in red so we can see with the arrow a little bit better. Now remember, we start at the terminal side just like always. And instead of going counterclockwise, now we're going to go clockwise. And we're going to go 330 degrees. Well, 330 degrees happens to land right here. Your terminal side would land in the exact same position. So you can add and subtract any multiple of 360 degrees to get a coterminal angle. Now, if I wanted to, in general, state what all coterminal angles are. Oops. The way I would write that is I would say it's 30 degrees plus 360 degrees times k, where k is any integer because we can add or subtract any multiple of 360 degrees to get a coterminal angle. Okay, so very similarly in number 2, we're going to come up with coterminal angles for theta equals pi over 3. Pi over 3 is in radians, so instead of adding and subtracting multiples of 360 degrees, we can add and subtract multiples of 2 pi. So to get the first coterminal angle, we can take pi over 3 and add 2 pi to it. Now to make this easier, we're going to want to find a common denominator, so I'm going to multiply by 3 over 3. I get pi over 3 plus 6 pi over 3, which equals 7 pi over 3. We get an example of one coterminal angle. Well, this is a positive coterminal angle. Let's find a negative one now. So we have pi over 3 minus 2 pi. And so we're going to find a common denominator again. Pi over 3 minus, we have 6 pi over 3. And we end up with negative 5 pi over 3. So these are both coterminal to pi over 3, but one is positive and one is negative. And so for, in general, all coterminal angles are of the form pi over 3 plus 2 pi k, where k is an integer. This notation is going to come in handy, especially when we get to solving trig equations. Okay, let's take a look at number 3. It says, find an angle with measure between 0 degrees and 360 degrees that is coterminal with the angle measure 1290 in standard position. Well, 1290, we're going to keep going around that circle quite a bit of times. And so we can subtract, remember, any multiple of 360 degrees that we want. So it turns out we want to figure out how many times we can pull 360 degrees evenly out of 1290. And so it turns out we can actually do 3. So if we have 1290 and we subtract off 3 times 360 degrees, we end up with 1290. Oops, actually, you can punch that in your, let's see, so 300 times 3, we get 900, so 1080. No, that's not right. 1293, okay, why can't I do math in my head right now? 300 times 3 is 900, whoops. And then 60 times 3 is 180. Oh, no, I did do that right. 1080. Okay. Okay. All right. So then we have 1290 minus 1080. And so we end up with 270 degrees. Let's see. 1290 minus. Oops. Oh, 210, sorry, 210. Okay, so we found a coterminal angle with 1290 degrees, and it is 210 degrees. So we can go ahead and say that the angle between 0 degrees and 360 degrees that lands in the same spot as 1290 degrees would be 210 degrees. Okay, let me go back. Okay, so number 4, we're going to do something similar. We are going to find an angle with measure between 0 and 2 pi this time that is coterminal with the angle measure 132 pi over 5 in standard position. So 132 pi over 5, we need to figure out how many multiples of 2 pi we can evenly take out. And I think it's actually quite a bit. So let's see. So we have 2 pi. And let's actually find a common denominator to make this a little easier. So we could do, instead of writing it as 2 pi, let's write it as 10 pi over 5 times what? How many multiples of that can we pull out? And it looks like actually we can pull out 13, right? And so we end up with 132 pi, over 5 minus 130 pi over 5, and we end up with 2 pi over 5. So it turns out that 2 pi over 5 is coterminal to 132 pi over 5. Okay, so now that we've discussed coterminal angles, let's go ahead and move on to the length of a circular arc. So this is kind of going back to a little bit of maybe what you saw in geometry. And so let's talk first about a little bit of vocabulary, some circle vocabulary. So the first key part that we need to have here is the radius. So let's start discussing the radius, which we always just use r as our variable. So the radius just goes from the center of your circle to any point on your circle. It's the distance. So this would be r. Okay. Now we use the variable s to denote the length of an arc. So we have arc length, and we're going to call that s. And so that's basically how much of the arc we are taking. We call that s. And then usually there's like a terminal side, right? So we stop here, and you could see that that's a little sector of our circle that we have there. Okay, and then last but not least, the measure of the central angle. And usually we use radians for this, but you could do degrees. I guess it could be radians or degrees. And so we usually just use theta for that. And so the central angle theta would be right here. Okay, so the length of a sector S is equal to r, the length of your radius, times theta. And so you could simplify this, and it would be theta is equal to your side length, S, over r. So you could solve for the length of your sector or that angle as well. Okay, and where this actually comes from is the length of your sector is actually a fraction of the total circumference. And so I like to show this. If I were to take just a fraction of the circumference, your area, your S, right, would be whatever theta is divided by 2 pi if it's in radians, or 360 degrees if it's in degrees, right? We can do 360 degrees. And remember, circumference is pi times diameter, or 2 pi r. So 2 pi r. And so if you notice, your 2 pi radians and 360 degrees, those cancel. And so you're left with theta times r. And so that's kind of where that equation comes from. Okay, so number 1, it says find the length of an arc of a circle with a radius of 10 meters that subtends a central angle of 30 degrees. So let's draw this out because it's a lot of vocabulary. So we have our circle. We'll put our center as close to the center as we can. The radius is 10 meters. So 10 meters. And the central angle is 30 degrees. So we can kind of get an estimate of what that would look like. This is about 30 degrees right here. And we want to find the length of the arc. That's S. Okay, so here we have S is equal to R, which is 10 meters, times your theta. Now, we want to actually convert this 30 degrees into radians. Actually, yeah, that's right. This, I know I showed you this, that it cancels out. We probably should have used 2 pi to show that a little bit more clearly, right? So let's actually leave this in radians. Theta is in radians. Okay, it works out actually, if you know how to derive the formula, you don't actually have to memorize this version of it. But this is a little bit mathematically easier. Okay, so 30 degrees, if we were to convert that, we'd multiply by pi over 180 degrees. So 30 degrees is pi over 6. So we'd multiply by pi over 6. And then so S equals 10 pi over 6, or you can actually reduce that to 5 pi over 3, and we are in meters. Okay. Okay, so for number 2, we're working backwards. It says a central angle theta in a circle of radius 4 meters is subtended by an arc length of 6 meters. We want to work backwards to find what the central angle would need to be. So we can draw a quick picture. And so we have our radius of, of 4 meters. And we have the arc length. We just don't know what theta is. I'm just going to kind of estimate. I don't know. We'll put theta right here. It might not be to scale. That's okay. But S is given to us as 6 meters. Okay, so you can either plug it into S equals R times theta, or you can solve for theta. So using theta equals S over R. Either way works, but we have that up there, so we might as well use it. Theta equals S, which is 6 meters. Okay, so 6 meters divided by R, which is 4 meters. So theta equals, now remember this is in radians, so 6/4. If we reduce that, it reduces to 3 over 2. And this is in radians. Okay. Last little section here, the area of a circular sector. And so once again, what we want to do is we'll kind of draw on our diagram just like we did before. We have a radius R. So R equals the radius. Okay. Theta is still going to be the measure of the central angle. And we're going to keep this in radians as well, just so it's a little less confusing with all the conversions. And so that'll open up a certain amount, right? Certain amount theta. And so essentially, instead of finding the length of the arc, we're now finding the area of the sector. So what does this area equate to, and how do we calculate that? So area, formula for this, is 1/2 R squared, so R squared times theta. Now remember, we're keeping this in radians. This actually comes very similarly from the fact that it's a fraction of the whole circle. And so it's theta over, well, we're in radians, so 2 pi of that circle, right? Times the whole area, which is pi r squared. So notice those pi's cancel out. That's where the 1/2 theta r squared comes from. Okay, so the last example says, find the area of a sector of a circle with a central angle 60 degrees if the radius of the circle is 3 meters. So let's see, find the area of a sector of a circle. Okay, the central angle is 60 degrees and we have the radius. Radius is 3 meters. Central angle is 60 degrees. Now we want to convert that to radians. So we have 60 degrees times, let's see, we want to multiply by pi over 180. Okay, 60 over 180 reduces to 1/3, so it equals pi over 3. Okay, so to find our area of our sector, it's 1/2 times our radius, 3 squared, times theta, which is pi over 3. So area is 1/2 times 9 times pi over 3. We're going to leave it in exact form, but we're going to simplify. So 9 over 3 is 3. So area is 3 pi over 2. Now, because it is area, we need to make sure that we're using units and it's square meters, right? So be really careful with that. So the area is 3 pi over 2 square meters. Okay, that is it for today's lesson. Thank you very much.